Hey folks, welcome to Chapter 2, Lesson 2, Statements, Conditionals, and Biconditionals. A statement is a sentence that is either true or false. The truth value of a statement is either true or false. A statement can be represented by a letter such as P or Q. The letter P here represents a rectangle as a quadrilateral. It's a statement because it's in the form noun, verb, noun, and I can assign a truth value to it. I can clearly say it's either true or false. In this case, a rectangle is a quadrilateral, meaning a rectangle is a four-sided polygon, true. Okay. The negation of a statement has the opposite meaning and opposite truth value of a statement. The negation of a statement can be represented by not P or by the symbol not P. Tilde P means not P. Okay, if P is a rectangle is a quadrilateral, what do you think not P is? It is a rectangle is not a quadrilateral. All right, a rectangle is not a quadrilateral, true or false? False. Not P will always have the opposite truth value of P. Two or more statements joined by the words and or form a compound statement. A compound statement using the word and is a conjunction, just like in English. A conjunction can be represented by P and Q or P and Q. The symbol means P and Q. It looks like an A, right? P and Q. A conjunction is true only when both statements are true, just like in English. Okay, P, a rectangle is a quadrilateral. True or false? True. A rectangle is convex. True or false? True. So what about P and Q? A rectangle is a quadrilateral and a rectangle is convex. True or false? True. Why? Because a conjunction is true only when both statements are true. True and true? Yes, your conjunction is true. Next, use the following statements to write a compound statement for each conjunction. Then find its truth value. Explain your reasoning. Well, let's go through these. P is the figure is a triangle. Is that true or false? That's true. The figure has two congruent sides. True. You see there's two tick marks here. The figure has three acute angles. False. Two acute angles and a right angle. All right, so what does this say right here? This says P and R. How do you know this means and? It looks like capital A, right? P and R. So first thing we need to do is translate this algebra into verbal. How do we do that? Well, P is the figure is a triangle. This means and R is the figure has three acute angles. So we write the figure is a triangle and the figure has three acute angles. Then we test the truth value of P. Is P true or false? True. Is R true or false? False. So what can we say about P and R? It is false. Why? Because in order for P and R to be true, both P and R must be true. It's very restrictive, these conjunctions. By the way, this triple dot means therefore. It's the universal symbol for therefore. Use the following statements to write the compound statement for each conjunction, just like before. Q and, how do we read this? Q and not R. Q and not R. All right, first thing, translate to verbal from algebra. This is algebra, translate to verbal. What do you get? The figure has two congruent sides and the figure does not have three acute angles. Truth value of Q, true. Truth value of not R, the figure does not have three acute angles. That's true. Therefore, what's the truth value of Q and not R? Definitely true. True and true, definitely true. All right. Why don't you try this on your own and come back? All right. P and Q. How am I going to translate this to verbal from algebra? The figure is a triangle and the figure has two congruent sides. Truth value of P, true. Truth value of Q, true. So truth value of P and Q is true. Remember, for a conjunction, an and statement, both statements have to be true for the conjunction to be true. How about this? Not P and not R. How would I write that? You might want to pause it. The figure is not a triangle and the figure does not have three acute angles. Not P. What's the truth value? False. How about not R? True. Therefore, not P and not R is false. Doesn't matter that one of the two statements is true. Both have to be true for a conjunction to be true. All right, a compound statement using the word or is a disjunction. Just like in English, a disjunction can be represented by P or Q or by this symbol, which means P or Q. A disjunction is true if at least one of the statements are true. Now, how are we going to remember this means P or Q? Remember in the last slide, we had an A-looking symbol, so it was P and Q. So when you get the V-looking symbol, it must be P or Q. P, the volume of a cylinder is pi r squared h. Is that true or false? True, you got it memorized. It's a math fact. Q, a cylinder is a polygon. True or false? False. P or Q, the volume of a cylinder is pi r squared h, or a cylinder is a polygon. True or false? True. The first statement was true, the second statement was false, but you only need one or the other to be true in order for the whole thing to be true. At least one truth is enough in an or situation. Or is much less restrictive than and. And true to get true, or at least one true. That's all you need. Use the following statements to write a compound statement for each disjunction, then find its truth value. Explain your reasoning. Okay, let's think about this. January is a fall month. True or false? False. January has only 30 days. False, and it's 31. January 1st is the first day of a new year. True. All right, let's look at this. How do I read this? P or R. Remember the symbol looks like this is looks like an A, so that's for and this one's got to be the other one, which is or. B looks like an or. All right, how do I translate this into verbal? Plug and chug, right? January has only 30 days, or January 1st is the first day of a new year. Is Q true or false? False. Is R true or false? True. Therefore, P or R is true. False and true, that'll get to true because you only need at least one true. P or Q. Well, January is a fall month, or January has only 30 days. What's the truth value of P? False. What's the truth value of Q? False. So what do we think for P or Q? It's going to be false. Yeah, therefore P or Q is false. Why? There's no truth value to be had here, anywhere. All right, you could pause this and come on back if you'd like for R or P. All right, the first thing you're going to do is translate. R or P becomes January 1st is the first day of a new year, or January is a fall month. Next thing we do is test the truth value of R. It's R going to be true, then P. P is going to be false. Therefore, R or P is true. At least one statement is true. Q or not R. January has only 30 days, or January 1st is not the first day of a new year. Okay, how about Q? False. Not R? False. Therefore, Q and not R is false. There's no truth value to be had anywhere. All right, a conditional statement is a statement that can be written in if-then form. A conditional statement can be represented by if P then Q, P implies Q, or this right here, which is read if P then Q. Again, this is read P implies Q, or if P then Q. Let's remember if P then Q. The statement after if is the hypothesis. So P is the hypothesis. The statement after then is the conclusion. So Q is the conclusion, right? If the hypothesis, then the conclusion. P is the hypothesis, Q is the conclusion. And this whole thing, if P then Q, is called a what? Conditional. Let's look at it one more time. P is the hypothesis, Q is the conclusion. And P, if P then Q, this whole thing is the conditional statement, conditional. All right, if P then Q, maybe if a geometric figure is a tetrahedron, then it is a triangular pyramid. What do you say? Is this conditional? If P then Q, true or false? True. A tetrahedron is what? It's the regular form of a triangular pyramid. All right. Many conditional statements are not written in if-then form. but we can rewrite them in if-then form. For example, points will be deducted from any homework turned in after Wednesday's deadline. Could you translate this into if-then? Sure. You could write, if a paper is turned in after Wednesday's deadline, then the points will be deducted. All right, why don't you try? If a mammal is a warm-blooded animal, can you convert to if-then? You have to add one word. If an animal is a mammal, then it is warm-blooded. Okay. How about a prism with bases that are regular polygons is a regular prism? Okay. Not something you've learned, but here we go. If a prism has bases that are regular polygons, then it is a regular prism. So many of these if-then statements, many of these conditional statements, if P then Q, are hidden in more colloquial language. We have to convert them to if-then. Why don't you try converting this one? Pause it and come back. All right. 4 quarters can be exchanged for a dollar bill. Translates into, if you have 4 quarters, then you can exchange them for a dollar bill. Basically use the language that's straight in here. Try another one. The sum of the measures of 2 supplementary angles is 180. Pause it. See how you do. All right. If 2 angles are supplementary, then the sum of their measures is 180. Notice we always have to insert these words, like we had inserted the word angle, or we inserted the word animal, just to make the if-then statement make sense. All right, to show that a conditional is true, you must show that for each case, when the hypothesis is true, the conclusion is true. To show that a conditional is false, you only need one counterexample. Strangely, if a hypothesis is false, the conditional will be true. How strange and counterintuitive. Stop and look at this slide with me. This is the hardest part of the lesson to accept. Ready? What's P called? P is called the hypothesis. What's Q called? Q is called the conclusion. What about this? How is this read? If P, then Q. And what's that called? That's called the conditional. Let's do it one more time. P is the hypothesis. Q is the conclusion. If P, then Q is the conditional. All right. This makes sense. When P is true and Q is true, if P, then Q is going to be true. Seems logical. How about if P is true, but Q is false, then if P, then Q is false. All right, no problems there. It seems intuitive enough, but this is the weird stuff. If the hypothesis is false and the conclusion is true, the conditional is true. If the hypothesis is false, but the conclusion is false, the conditional is true. Whenever the hypothesis P is false, the conditional will always be true. All right. This is hard to believe. This is hard to accept. This is hard to explain. Let's just say you're taking it on faith for now, based on what mathematicians have proven and explained. That's probably highly unsatisfactory in explanation, but let me just say this is strange and counterintuitive, and you're going to have to memorize it. All right. Whenever you get a false hypothesis, you're going to get a true conditional if-then statement. Determine the truth value of each conditional statement. If it's true, explain your reasoning. If it's false, you have to give at least one counterexample. Okay, if you divide an integer by another integer, the result is an integer. Well, we have to know what an integer is. The integer is the set of numbers ... -3, -2, -1, 0, 1, 2, 3, ... Basically all the counting numbers, the negative version of the counting numbers, and 0. If you divide an integer by another integer, the result is an integer. True or false? False. Here's one counterexample. Integer 1 divided by the integer 2 equals 1/2. 1/2 is not an integer. It's not a positive or negative counting number. It's not an integer. Remember, if you're going to claim that a conditional is false or any statement is false, you just need one counterexample for that. If next month is August, then this month is July. What do you say? True or false? Well, obviously true. All right, if the hypothesis is true, then the conclusion must be true. It is in this case. If a triangle has 4 sides, then it is concave. What do we think about this conditional, about this if-then statement? True or false? Okay, before you answer, or you scream false, or whatever you're going to say right now. If P, then Q. If P, then Q. P is a triangle, it's 4 sides. Q is, it is concave. Is P, the hypothesis P, is that true or false? Well, it's obviously false. A triangle never has 4 sides, right? This is just false. What happens, what we say happens if the hypothesis is false? The conditional is automatically true. This is true because if the hypothesis is false, triangle never has 4 sides, then the conditional is true. Counterintuitive, strange. Looking it up and thinking about it might be a really long project, but let's accept it for now. If angle A is an acute angle, then the measure of angle A is 35 degrees. All right. Does it sound true or false to you? If it's false, you need a counterexample. It is false. Here's an easy counterexample. The measure of angle A is 55 degrees, right? If A is an acute angle, well, 55 is certainly acute, then the measure of angle A is definitely 35. No, it could easily, it would be 55 in that case. And there's many counterexamples here. You see it? If this said the measure of angle A is 35, if this said if the measure of angle is 35, then angle A is an acute angle. Of course that's true. But if angle A is an acute angle, then the measure of angle A is 35. False, because there's many counterexamples. How about this one? If the square root of x equals -1, then -1 squared equals -1.
The answer is 1.
Okay. Well, this is a conditional. If P, then Q. So let's look at each piece. P. Is P true or false? Square roots of x equals -1. What do you think? Is P true or false? The hypothesis true or false? Hypothesis is clearly false. I don't care what number you stick in for x, you're not going to get a negative number out. Put in 16, you get out 4. Put in 9, you get out 3. If you put in a number like -9, you're going to get out 3i, which is imaginary. Certainly not -1. This will never happen. Therefore, the hypothesis is false. If the hypothesis is false, what can you say about the whole conditional? It is true. Counterintuitive, but there you go. By the way, is the conclusion true or false here? -1 squared. Does that equal -1? No, that equals 1. That's false too. -1 times -1 is 1. It doesn't matter if it's false, false, or false, true. Either way, the whole conditional will be true. If the hypothesis is false, then the conditional is true. All right. Other conditional statements that are based on given conditional statement are called related conditionals. These include the converse, the inverse, and the contrapositive. All right, read this with me. Conditional. If P, then Q. Converse. If Q, then P. Inverse. If not P, then not Q. Contrapositive. If not Q, then not P. These are math facts, folks. You just need to memorize. The only person who can memorize these are you. So go ahead and memorize them now. Take 3 minutes. That's what I did in class. Take 3 minutes to just memorize these and test yourself. That you can say to yourself, okay, converse. And you should be able to say, if Q, then P. Or say to yourself, contrapositive. What was that? If not Q, then not P. Just like that. Don't be saying the words arrows, right? All right. And then once you've done that, realize this. Statements with the same truth value are logically equivalent. Conditional and its contrapositive are logically equivalent. The converse and the inverse are logically equivalent. What am I saying? If the conditional is true, the contrapositive is true. If the converse is true, the inverse is true. If the conditional is false, the contrapositive is false. If the converse is false, the inverse will be false. Always. Because the conditional and the contrapositive are logically equivalent. They always have the same truth value, and the converse and inverse are logically equivalent. They always have the same truth value. Like two different ways of saying the same thing. All right, let's look at some examples here. If P then Q, if the measure of angle A is 35, then the measure of angle A is an acute angle. True or false? True. Let's do the converse. What do we do for the converse? We just switch P and Q. So if Q, then P. If the measure of angle A is an acute angle, then the measure of angle A is 35. Is that true or false? False. Can you give a counterexample? Sure. The angle 36 degrees. Inverse. If the measure of angle A is not 35, then the measure of angle A is not, then angle A is not an acute angle. Let's think about that. Not 35, then it can't be acute. Nope, again, the angle 36 would certainly work. Right? An angle measured 36 would work. So this is false. And we'd expect that because the converse and inverse should have the same truth value. They're both false. Contrapositive. What do we do for contrapositive? We flip P and Q and negate them. So if not Q, then not P. If angle A is not an acute angle, then the measure of angle A is not 35. True or false? True. And we'd expect that. The contrapositive and conditional should have the same truth value. In this case, both true. All right, rewrite the conditional in if-then form. Then, write the converse, the inverse, and the contrapositive of each conditional. Then determine whether each of those related conditionals is true or false. If false, you need a counterexample. So there's a lot to do in this problem. Ready? Lions are cats that can roar. How would you convert that to an if-then statement? If an animal is a lion, then it is a cat that can roar. Lions are cats that can roar. If an animal is a lion, then it is a cat that can roar. Do you see it? Insert the word animal. All right. Is that conditional true or false? If an animal is a lion, then it is a cat that can roar. Definitely true. Okay. How about a converse? To switch them. If an animal is a cat that can roar, then it is a lion. False. Okay. I can think of many counterexamples. How about a tiger? A tiger is certainly an animal, is certainly a cat that can roar, but it's not a lion. Okay, one counterexample will do. Inverse, it's just not P, not Q. If not P, then not Q. If an animal is not a lion, then it is not a cat that can roar. Let's think about this. Okay, maybe it's a tiger. Oh, but wait, a tiger is a cat that can roar, so that's also going to work as a counterexample. And like the converse and the inverse are both false because they should both be false. Finally, contrapositive, if not Q, then not P. If an animal is not a cat that can roar, then it is not a lion. Is that true or false? That's true. If an animal is not a cat that can roar, then it's definitely not a lion because lions are cats that can roar, right? And the conditional and the contrapositive both have the same truth value of true. All right. Go ahead and try this one. Remember your steps. You're going to convert to if-then language, then come up with the converse, inverse, and contrapositive, and then get the truth value of all of them. If you have a false truth value, you need a counterexample to prove your case. All right, so pause it and come back. All right, the conditional. Sorry, so two angles that have the same measure are congruent. If two angles have the same measure, then they are congruent. True or false? True. Okay. That's basically the definition of congruence in modern terms. Okay, next is converse. If two angles are congruent, then they have the same measure. That's also true. Inverse, not P, not Q. If two angles do not have the same measure, then they are not congruent. That's true. Contrapositive, if two angles are not congruent, they do not have the same measure. That's true. Okay, in this case, everything's true. Pause, you try. All right. A hamster is a rodent. What's the one word you have to add in here? Yeah. If an animal is a hamster, then it is a rodent. True or false? True. All hamsters are rodents, right? Converse, if an animal is a rodent, then it's a hamster. True or false? False. There's a counterexample. It's very easy to be a mouse. Okay. Sure, a mouse is a rodent, but it's not a hamster. Inverse, if an animal is not a hamster, then it is not a rodent. Now, again, the mouse will work as a counterexample, won't it? A mouse is not a hamster, but certainly is a rodent. And finally, contrapositive, if an animal is not a rodent, then it does not. Then it is not a hamster. If an animal is not a rodent, then it is not a hamster. Well, that's going to be true as well. All right, notice the conditional and the contrapositive, both true. The converse and the inverse, both false. There's a logical equivalence between the conditional and the contrapositive and the converse and inverse. Last idea here. A conjunction, an and statement, remember this is the symbol for and because it looks like an A. A conjunction of a conditional statement, if P then Q, and its converse, if Q then P, is called a biconditional statement. A biconditional connects a conditional and its converse with the words if and only if. A biconditional can be represented by P, if and only if Q, P, if P then Q, and if Q then P, or this thing right here is read as P, if and only if Q, just like this. P, if and only if Q. This is read P, if and only if Q. Now, your textbook isn't using that symbol yet, but that's how everybody reads it. P, if and only if Q. And it means if P then Q and if Q then P. A biconditional is true only when both of the conditionals is true. Both when the conditional and its converse are true. Okay. So if P implies Q is true and Q implies P is true, then the biconditional will be true, and only then will it be true. Conditional. If P then Q. If A is a right angle, then the measure of angle A is 90. True or false? True. Converse. If the measure of angle A is 90, then angle A is a right angle. True. Therefore, we can say about the biconditional, angle A is a right angle if and only if the measure of angle A is 90. That's true. See, both conditionals were true, therefore the biconditional is true. Conditional is true. Converse is true. Both directions, then the biconditional is true. A biconditional is essentially a definition, right? Please note that all definitions are biconditional statements. When you think about mathematical definitions, these are biconditional statements. That's why they work in both directions. All right. You have homework. Your homework is either the standard set or the honor set, depending whether or not you're in standard or honors. I'm not sure if the honors problems here are cut off. There should be 20 problems, but certainly the assignment is in Lion's Den for you. All right. Thanks, folks, for listening.